This video is the next video in the algebra set of videos, and in particular in this video we're going to focus on surds. Irrational numbers such as square root 5, square root 8 or square root 13 are generally called surds. In the even surd ordinary level, you need to be able to express a surd in its simplest form and perform simple operations such as addition, subtraction, multiplication and division on surds. To do this, there are three main facts that will help us with doing all of this. These three facts you can see below, and I'm going to go through an example with each one. Fact 1, we have that the square root AB is equal to the square root A square root B. So for example, to explain this, if we're looking at example 7.1, it says simplify square root 20. Now we can rewrite 20 as 4 multiplied by 5, and I'm going to do that to begin with. So square root 20 is equal to the square root of 4 multiplied by the square root of 5. Using fact 1 then, we can rewrite the square root of 20 as the square root of 4 multiplied by the square root of 5. Now the square root of 4, to figure that out, it basically is what number multiplied by itself will give us 4, and that is 2. So the square root of 20 can be rewritten as 2 square root 5. You might also say that, well, for example, square root 20 can be rewritten as the square root of 10 multiplied by 2. However, when applying the rule, we get the square root of 10 multiplied by the square root of 2, which doesn't break down easily. And you might also say, well, we could break down 10 further, which is 5 multiplied by 2. And, well, that does give us the square root of 5 times the square root of 2 times the square root of 2. And that will be perfectly fine as well. This can be simplified further, but we will do it when we're looking at example 7.3. The main point to take from this is when you have a number, you're able to split that number into two numbers that multiply by each other to make that number, and you can separate out the surds then. Usually you're trying to find a way that when you separate out the surds, that one of them will break down, or you'll be able to complete the surd to give a whole number. Looking at fact number 2, if we have the square root of a fraction where we have a over b, that's equal to the fraction of square root a over square root b. And that can be easily explained by looking at example 7.2. Here we have the square root of 1 over 9. We can rewrite the square root of 1 over 9 as the square root of 1 divided by the square root of 9. Simplifying that down then, well, the square root of 1 is just 1, as 1 times 1 will give us 1. And then the square root of 9 is 3, as 3 times 3 is equal to 9. The best thing about surds is if you're unsure, you can always type in the square root of 1 over 9 into your calculator and it will give you the answer of 1 over 3. Similarly, with the first example where we were looking at the square root of 20, if you type in the square root of 20 into your calculator, it will give you an answer of 2 root 5. Looking at fact number 3 then, we have the square root a multiplied by square root a is equal to a. And again, this is best explained by going through an example. But before we do that, I just want to talk about square roots a little bit. So in fact 3, we have the square root of a multiplied by the square root of a. That could be rewritten as a to the power of a half times a to the power of a half, as the square root of a number is the same as the number to the power of a half. Here we have a to the power of a half times a to the power of a half. When we're looking at this, this is laws of the indices. And when we have the same number multiplied by itself to a power, we add the powers. This will become a to the power of a half plus a half. And that's going to be a to the power of 1. And as you can see, that's exactly what fact 3 says. It says the square root of a times the square root of a is equal to a. Looking at an example then, we have the square root of 7 multiplied by the square root of 7. Now applying the fact, we just know that the answer is 7. However, looking at what's actually happening is, that is 7 to the power of a half times 7 to the power of a half. The 7's multiplied by each other. When we have powers, the powers are added. This will become 7 to the power of a half plus the power of a half, meaning that we'll end up with 7 to the power of 1, which is the same as writing 7. Now, going back to example 7.1, you can see here that we have square root 2 multiplied by square root 2 beside where we have multiplied by the square root of 5. Using fact number 3 here, this can be rewritten as the square root of 5 times 2, as the square root of 2 times the square root of 2 is equal to 2. And usually when we have a square root and a number, we write the number before the square root, as sometimes people can get confused on what's underneath the square root if we wrote it as 5, 2. People might think that the 2 is underneath the square root and that you've just forgotten to extend the square root over the 2, or they might think that it's square root 52. If you ever have two numbers that are multiplied by each other, where one of the numbers has a square root, always write the square root last and keep the other number in front of it to make sure that people don't get confused and think that you mean the other number is underneath the square root. Now on the next page, I'm going to go through a few examples of working with surds. Example 7.4 says simplify square root 5 plus square root 45 minus square root 20. To do this question, I have square root 5 to begin with, which can't be broken down any further, so I'm just going to leave a square root 5. Square root 45, well, that can be broken down into 9 times 5. And then minus 20 can be broken down into 4 multiplied by 5. That means we'll end up with square root 5 plus the square root of 9 times the square root of 5 minus the square root of 4 times the square root of 5. And that's fact 1 that we were looking at on the previous page. Here we'll end up with then the square root of 5 plus the square root of 9, which is 3, times the square root of 5, and minus 2, as the square root of 4 is 2, times the square root of 5. This then turns into almost like algebra, as we have 1 square root 5 plus 3 square root 5 minus 2 square root 5. So 1 plus 3 will give us 4, and minus 2, that will give us 2 root 5. And the answer then for square root 5 plus square root 45 minus square root 20 is 2 root 5. Example 7.5 then, it says here simplify the square root of 6 times the square root of 2. That is still fact number 1, as we can rewrite this as the square root of 6 times the square root of 2, which can be rewritten as the square root of 6 times 2, which will give us the square root of 12. And we can simplify this as further as well, as we can rewrite this as the square root of 4 times 3, which can be rewritten as the square root of 4 times the square root of 3, which will give us 2 root 3. Just to note as well, you can also type square root of 5 plus square root 45 minus square root 20 all into your calculator, and it will give you the answer of 2 root 5, so you'll know if you've got the answer correct or not. And you can also write the square root of 6 times the square root of 2 into your calculator, and it will give you the answer of 2 root 3. So again, you can check your answer to see if you're correct or not. Example 7.6 says simplify 2 root 3 multiplied by 3 root 5. This is very similar to the previous example, except this time we have numbers outside of the square root 2. But in this example, all we have to do is multiply the numbers outside the square root by the numbers outside the square root, and the numbers underneath the square root by the numbers underneath the square root, and keep them underneath the square root. So this will become 2 times 3 multiplied by 3 by 5. Simplifying that then, this will become 6 by 3 by 5, which is 15. Again, if you type this into your calculator, you'll get the answer of 6 root 15. Next, we can do example 7.7. In this one, we have the square root of 32 multiplied by the square root of 48. Before we multiply them, we can actually simplify both square roots. Square root 32 can be rewritten as the square root of 16 multiplied by 2, and 48 can be rewritten as 16 multiplied by 3. These then can be rewritten as the square root of 16 by the square root of 2 multiplied by the square root of 16 by the square root of 3. Square root of 16 then is 4, and we'll get 4 root 2 multiplied by 4 root 3, which will then give us 4 by 4, which is 16, underneath the square root then of 2 times 3, which is 6. We've then finished this question and we've simplified the square root of 32 by the square root of 48, which gives us 16 root 6. If you want to, of course, you can type square root 32 times square root 48 into your calculator. The answer you'll get is 16 root 6. The final example we'll look at here is example 7.8, and in this example we'll be multiplying 2 root 5 minus 3 by 2 root 5 plus 3. We deal with this the very same way we deal with algebraic expressions. We're going to multiply the first term in the first bracket by the second bracket, and the second term in the first bracket by the second bracket. I'm going to move this up here just to give me a bit more space, but the first term in the first bracket is 2 root 5, and I'm going to multiply that by the second bracket, which is 2 root 5 plus 3. Then we have the second term in the first bracket, which is minus 3, and we're multiplying that by the second bracket, which is 2 root 5 plus 3. Next then, we multiply out the brackets. So we're going to multiply the 2 root 5 by the 2 root 5, the 2 root 5 by the 3, the minus 3 by 2 root 5, and the minus 3 by 3. We first of all have 2 root 5 by 2 root 5, so the 2 by the 2 will give us 4. And we'll then get 5 times 5 underneath the square root, which will give us 25. We'll then have 2 root 5 by 3. Now there's no square root here, so we just multiply the numbers outside the square root by each other. So it becomes 2 by 3, which is 6, so we'll get 6 root 5. Similarly, with the minus 3 by 2 root 5, we'll get minus 6 root 5. And then we'll get minus 3 times 3, which will give us minus 9. Simplifying this then again, we'll have 4 root 25. Now 4 root 25 will give us 4, and then root 25 or square root 25 will give us 5. So we'll end up with 4 times 5. We also have plus 6 root 5 minus 6 root 5. So that will give us 0. And then we have minus 5. Here we have 4 times 5 then, which will give us 20. And we have minus 9. Meaning we'll then have 20 minus 9, which will give us 11. As always, when we're dealing with questions with surds, if you wanted to, you could type all of that into your calculator and you would get the answer of 11 and you'd know that you're correct. We've now gone through 5 examples on this page where we're looking at working with surds in different scenarios. If you can do and understand all of these questions, you should be able to answer any other type of question on surds. However, if you find yourself stuck with one, please let me know and I can help, or I can make a video on those type of questions too. That brings this video to an end.